Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem, just attempt to solve it, talk through my thought process, and hopefully it's useful to someone watching this. So the problem I'm going to be going through today or attempting to solve is from the LeetCode 150 and is evaluate reverse Polish notation, LeetCode 150. So, going to read out the spec here. You're given an array of strings, tokens, that represents an arithmetic expression in a reverse Polish notation. Evaluate the expression, return an integer that represents the value of the expression. Okay, the valid operations are plus, minus, multiplication, and division. Each operand may be an integer or another expression. Division between two integers always truncates towards 0. There will be no division by 0. The input represents a valid arithmetic expression in a reverse Polish notation. And the answer and all intermediate calculations can be represented in a 32-bit integer. Okay. So 2, 1 plus 3 times. Okay. So I'm going to look up what this is, because I've never heard of it. In reverse Polish notation, the operators follow their operands. For example, to add 3 and 4 together, the expression is 3, 4 plus, rather than 3 plus 4. The concept of okay, so this is getting to what we want here. The concept of a stack, a last in, first out construct, is integral to the left to right evaluation of RPN. In the example 3, 4 minus, first 3 is put onto the stack, then the 4. 3 is put onto the stack, then the 4. The 4 is now on top and the 3 below it. The subtraction operator removes the top two items and performs 3 minus 4, puts result minus 1 onto the stack. The common terminology is that items are pushed onto the stack and removed items are popped. Okay, let's have a look at this again. Here. So if we start off with this, we do times 3. So what we're going to be timesing by 3, we're going to be timesing plus. This is confusing. Let's have a look at what it said about it being a stack. It said that in the example 3, 4 minus, first the 3 is put onto the stack, then the 4. So now the 4 is on top and the 3 is below it. Yep. The subtraction operator removes the top two items from the stack, performs 3 minus 4 and puts a result of minus 1 onto the stack. Okay, so let's have a look at this again. So we take 2, 1 and we do 2 plus 1, which is 3. So let's take something like this, and we'll go into our notes and we will try and work through it. So this is LeetCode 150. Let's mark down some ideas. So let's just escape these characters because it's not going to like this. This and this. Cool. This is in italics for some reason. There we go. So two, 1 plus 3. Yeah, okay. So the stack is going to be equal to 2, then the stack's going to be equal to 1, then we get plus, so we do 1, oh no, the stack's going to be equal to 2, 1, 2, so we do stack is equal to 3, right, because we do 1 plus 2, and then stack is going to be equal to 3, 3, and then we do 3 times 3, which is 9. So at a high level, we say iterate through tokens, add token if token is a number, add it to the stack if token is an operator, add or we'll say pop the last 2 items from the stack, perform operation on it, then add the result back to the stack. And then we're going to return a result left in stack. So this is kind of like a high level kind of thing of what I'm going to try to do. So let's take this, comment it out. So for token in tokens, we also need a stack. What we're going to say here, if token dot is num, we're going to print token. Let's just see if this works first of all. Okay, that would work as our num. Okay, so we get 2, 1, and 3. So that's right. So we're going to do stack dot append token. Cool. Then what we're going to do is we're going to say if token, or we're going to say else. We're going to do stack dot append, or stack dot, or we can say stack dot append or we can just, we'll say elif token is equal to plus. If the token is a plus, we're going to do stack dot append, and then we're going to do stack dot pop converted to an integer plus int stack dot pop. And we'll just repeat this. I did not try to submit that. Don't know why that did that. So we've got plus, minus, times, and division. And we're just going to do one last int wrapped around it, just so that it gets rounded down or truncated rather. And it's going to be minus here, times here, and divide here. And then we're just going to say return stack at index 0. Hit run. Okay, let's try it now. Just gonna make sure that the first one worked. Did we get 9? Oh, for the multiplication we don't... So let's think. We see that 2 is a number, so we append it. We see 1's a number, we append it. Then we add back in 2 plus 1, so we get 3 added to the stack. And then we see number 3 here is added to the stack, so we get 3 times 3, which is 9. Oh, there can be more than one number. Okay. Okay. Let's have a look at this. Is there any examples? There's no kind of examples here. I guess what we could try doing is we could try doing while the length of stack is not equal to 0. We can try that. Oh, we've already done it here. And same here. Let's try that. Or we could see while it's greater than 1. Let's try this. Okay. Hmm. So it does. So in this example here, it gets 9 right, but these two don't seem to work. This returns 50, but it should have been 22. Um, okay, let's see. Let's see if this is a bit. Okay, I think this is different. I don't want to look at something that's like a solution. Um, the idea of RPN is you put the operator afterwards rather than in between. Well, you can probably work out what it means. It's a bit more systematic. You're going to keep a stack of numbers. If you reach a number, you put it to the top of the stack. If you reach an operator, you remove the top two numbers on the stack, apply the operator to them, and then put the resulting number onto the stack. Ah, okay. So that should be right. So you take the two. Okay, take the top two. So the way that I had it should be fine. I'm going to print the stack every time just so we can try and figure out where the errors come from. Okay, so line 14. We get an error. Let's print the stack there. Okay. So pop from empty list. Hmm. we do stack.append stack.pop times stack.pop. The list isn't empty. I think it's because I'm doing it in the same line. What I could do is I could say something like operand 1 is equal to stack.pop, operand 2 is equal to stack.pop. Then what I could say is I could then say here, I need to convert this to an integer. Same here. What I could say is I could say just operand 1 plus operand 2. Try it here, 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 and here with this again converted to an integer. Okay. Invalid syntax. elif token is equal to this. I don't know why that's saying that's invalid. Why is it invalid? Okay, let's see what happens here. So here it's 10 for some reason. It's a bit weird. So oh, I've put these all to plus, which is wrong. This should be minus. This should be times. This should be divide. That shouldn't change anything. Okay, so we add 10, 6, 9, 3. And then we do this, which takes it to... It should be 10, 6, 11. And then 11 times minus 11 is... Okay, let's print the stack at the end of each round here, each iteration. So we get 10, then we add 6, then we add 9, then we add 3. let's print these two operands. So we get 9 and 3. Okay. And since the token is a plus, we append 3 plus 9, which is 12. Oh, that's what I've done. Operand 1 plus operand 1. Should be 2. I don't know how I missed that. Okay, let's try this again. Okay, so we get 12. Okay, and then we get minus 11. But it doesn't look like it doesn't look like minus 11 gets added. So 10, then 10 gets added, 6, then 6 gets added, 9, then 9 gets added, 3, then 3 gets added, plus, so 3 and 9 gets added to 12, minus 11, but minus 11 doesn't get added. Oh, because minus this negative doesn't get counted. What we can say is we can say if token, but not including the first characters. So from 1 up until the end, let's say that. Is that going to work? What is this, line 7? Oh, dot is al num. Is it 2? 2 of these? We'll look up check if number Python is numeric. Okay, let's try that. If token dot is numeric. Let's try that. Okay, when we get to here, it still doesn't get added. So we can see 10 is numeric, so is 6, so is 9, 3, but 11, minus 11 doesn't get counted. check if string is number. Can we do negative numbers? We can say, I don't know why what I was saying wasn't working, so can we say print token from index 1 and up until the end? So we get 11. Okay. If token is numeric, or we could say or token from index 1 till the end dot is numeric. That should hopefully mitigate this. Okay, does minus 11 get counted here? Minus 11 is numeric, okay. Where does it not work then? I think it's maybe the other way around. Operand 2, operand 1. I think that might be what it is. There we go. All 3 cases are accepted. Let's hit submit and hope this works. Oh, no. Okay. 18 is not a valid value for the expected return type of integer. Oh, okay. That's why. So we need to do when we append it, we want it to be an integer as well. We always want to make sure it's an integer. Let's hit run. This should work. Okay, nice. Hit submit. Hopefully there's no more errors. Net. Oh, right, okay. That was a bit stupid. I left all the print statements in. Take this away, take this away. And let's hit run. Nice. Okay, submit. Don't want to have to submit this again. Nice. Okay, it's very slow, but it works. So thank you very much for watching the video. I found that this reverse Polish notation was actually kind of an interesting idea. It's something I'm maybe gonna have a look into, like the history of it. Seems very interesting. But anyway, thank you very much for watching the video. Hope it was useful to you in some way, shape, or form. If it was, please leave a comment. I love discussing these problems and their solutions. So if you had some other solution that was maybe a bit more different or efficient, or just different in any way, I love discussing these problems and their solutions. So yeah, thank you once again for watching the video, and I hope you have a great day.